Okay, so this is our first proof example. So given CB and AC are congruent. So we'll start with the given. And we can mark that on the diagram. As soon as we kind of write it down, we know we're using it. So CB is congruent to AC. I want to prove that L bisects AB at C. So I need to go back and look at my definitions. What do I know about two congruent segments? Because some of you might be thinking, well, because it's congruent, it bisects. Like, what do we do here? So we're going to go back and look at our definitions. Our, let's see, segment bisector definition said, as an if-then, if it's a segment bisector, okay, if it's a segment bisector, then it's its midpoint. In fact, a good spot to look would be the slide where we kind of compared the two right after that. That's right here. So right now we have congruent segments. So if you use this, it can tell you what you have to do, right? I have congruent segments. Congruent segments goes with midpoint definition. It doesn't go with definition of segment bisector. So if I go to my congruent, or if I use that as my reason, so I'm going to say congruent segments. If I have congruent segments, then I have a midpoint. That's the definition of midpoint. So because I have congruent segments, I know that C is a midpoint of AB, segment AB. It's my second statement. My reason, instead of law of detachment, I'm using the law of detachment. I have an if-then statement. If I have a segment split up into two congruent segments, then the point in the middle is the midpoint. That's my if-then. And I have the true given for my hypothesis. But instead of using law of detachment for these units moving forward, we're going to use the definition that has that true conditional statement. So my reason is definition of midpoint. And again, I know I'm using definition of midpoint instead of definition of segment bisector because of my if-then. I literally have under step 1 and step 2 congruent segments and midpoint. So if I go back and look up, I have congruent segments and midpoint. Now once I have a midpoint, I can then go to segment bisector. So if C is a midpoint, then line L, which contains C, we can see that, bisects segment AB at point C. That's my definition of segment bisector. So I'm going to use my definitions in this unit as my reasons in my proof, just like I use the law of detachment. Every time I write down a definition, I should be able to do this. If I'm using as a reason definition of midpoint, I should be able to put a box around the if and the then, and that if and that then should match this definition. And that's all proofs are. Okay, again, if I want to use definition of segment bisector, then I put a box, kind of, in my head around this statement. If I have a midpoint, then the line that goes through the midpoint is the bisector. I need to make sure that that matches the definition of segment bisect, and it did. So that's an example, first proof example for Unit 2.